In the previous lesson, we looked at control flow expressions. So we saw pattern matching, we saw try-catch expressions for exception handling, we saw for loops and for expressions, and we saw if-else expressions. That was sort of the simplest one. We saw how expressions in general compose, and that was a very useful property. And based on that, we were able to put together a simple calculator. So the calculator works. It could use a little bit more error handling, but that's okay. But it is pretty simple. It really only does one thing. It parses the postfix notation expressions that come in and computes the value of those expressions. Perhaps we'd also like our calculator to be able to do other things with the expression that it parses. So for example, we're parsing postfix expressions. Perhaps we'd like to be able to translate them to infix expressions, which is more familiar to us. Or perhaps we'd like to translate them to XML or JSON if we're implementing like a web service, for example. So we'd like a little bit more flexibility, and probably the most familiar way of introducing that sort of flexibility is using an object-oriented style. Object-oriented style can also help us with this kind of problem. Right? We had a lot of copy and paste code up here, where really there was only one thing different between each of these operations, and that was the actual operation itself. Stack.pop, stack.pop, and stack.push. Well, that's all just copy-paste. So we'd really like to be able to write that once and perhaps have some sort of a class hierarchy that encapsulates the variety of behaviors here. So as a way to get started on looking at Scala's object-oriented features, what we're going to do first is just introduce some packages just to keep things clean. Packages in Scala work pretty much the same way as they do in Java. So I'm going to create a new package. We'll call this one calculator. And we'll create another new package called Cookbook. We're going to use Cookbook as an example for exploring Scala's object-oriented features. So let's move our calculator.scala into the calculator package. And by the way, you'll notice if you open it back up again, you'll notice that the package declaration has been placed at the top of the file by Eclipse. Okay. Now let's create a new class inside Cookbook. We'll call it Cookbook. And there we go, so we get sort of an empty class. Now one thing before we write any code is that it's actually fine, if you have an empty class, to completely leave off the class body. Now let's save that and go over to the console. So we can import the Cookbook class from the Cookbook package. So we'll say import cookbook.cookbook. And now we can say something like new cookbook. So we've created an instance of the cookbook class. We call that object instantiation. And when we instantiate it, the interpreter shows us, okay, the result of that expression was of type cookbook. And the string representation is not very interesting. It just shows us the memory address at which that object resides. Okay, so let's exit out of there. All right, so we want to fill out Cookbook a little bit more now. We know that Cookbook is essentially a collection of recipes. So we should have a field representing that. The way that we do fields of a class in Scala are just the same as we do fields in Java. They just belong inside the class body. So we'll say var recipes. You might wonder why I'm using var here instead of val, after I said about how we generally prefer to use val. We generally prefer immutable data. Just bear with me, we'll switch to val very soon. So we've said that recipes is going to be some kind of collection. So then the question is, what kind of collection should we use? Well, just for fun, let's say we'll use a map. A map of recipe names, and those will be strings, to recipe objects. Okay. Now we have to go and define the recipe class. So let's do that. Class recipe. And recipe is going to look much the same. It'll have a list of ingredients. We'll say the ingredients are just strings for now to keep things simple. And a list of directions. Okay. So we can save this, and we'll go back to the console. So now we have two classes that we need to import, and there are a couple ways to do that. I want to try to keep it concise, so I can say something like import cookbook dot, and then I can actually provide a list here. This is something that you can't do in Java. I can say cookbook dot recipe and cookbook. All right, so I've imported two things. Or if I wanted to do an even shorter hand, I can just say import cookbook dot everything. That also works. Notice the underscore there. We've seen underscore in pattern matching before, right? The underscore pattern was a pattern that matched everything. Well, underscore here is the wildcard import. It imports everything from the package that you specified. So those are two alternatives. You can use either one. Okay, so let's create a cookbook that contains a recipe for peanut butter and jelly sandwiches. Val cookbook is equal to new cookbook. Okay. And let's say val recipe is equal to new recipe. So right now the cookbook and the recipe are empty. Right, the recipe has an empty list of ingredients, an empty list of directions, and the cookbook has an empty recipes map. So let's populate the map. Cookbook.recipes equals map from, let's call this one P, B, and J to recipe. All right. Now we need that recipe to actually contain something as well, so we can say recipe.ingredients is equal to a list containing peanut butter, jelly, and we're going to need some bread too. And recipe.directions is equal to, here let's just make a list with one direction, which is put the peanut butter and jelly on the bread. Okay. Now we can verify that everything is wired up the way it ought to be, so I can go and look in the cookbook. I can say cookbook.recipes, and we'll get the recipe associated with the key P, B, and J. And that should give us a recipe object. And we should also be able to get the ingredients from that recipe, as well as the directions. All right. So far, so good, but we saw that the process of doing this, the process of creating and populating these objects, was somewhat cumbersome. We had to instantiate the object in one line, and then populate each field on subsequent lines. Now, typically the way that we do that, let's say in Java, is using constructors. So that's the next thing that I want to look at. Let's exit the console and go back to our cookbook. So the way that we create a constructor for an object in Scala is actually just to specify that the class takes parameters just like a method does. So we can say that recipe takes ingredients of type list of string and directions of type list of string, and cookbook also takes recipes of type map string recipe. So now the question is how to wire up these constructor arguments to the corresponding fields. Now if this were Java, we would say something like, var ingredients is equal to ingredients, and directions is equal to directions. But in Scala, this gives us a compiler error. It says that this is an ambiguous reference. So we can't do things quite like that. We could disambiguate by putting, let's say, a $sign or something terrible in front of the variable names, and then we're okay. But that's really poor style, and turns out actually to be unnecessary anyway. So let's undo that. And let's do this the right way. It turns out all we need to do is we can actually delete the class body, and right here we can specify that these constructor arguments are actually fields. We can just say val and val there, and these become fields of the recipe class. Likewise here in cookbook, we can say that recipes is a val as well, and so that becomes a field of the cookbook class. All right, so in this case, our constructor really only does one thing, which is to initialize fields. That turns out to be a very common case, So they make it very concise here. But let's say we wanted a constructor to do something else as well. Well, it turns out that the class body, the same place where you have your field declarations and your method declarations and so forth, it turns out that the class body is also the body of the constructor. These all just sort of lump together. So if I want, for example, to print the ingredients and the directions in recipe, I can just do that right here. I can say print line ingredients and print line directions, something like that. And I can do the same thing for cookbook as well. Okay, now let's go back over to the console again and show how that works. So let's define a recipe. So val recipe equals new recipe list of peanut butter, jelly, and bread. Put peanut butter and jelly on the bread. There we go. So now when we construct this object, it's populating the fields and it's calling a print lines. Now, let's say we wanted to provide some defaults here, because before, when we had these declared as vars, we had the defaults of empty lists and empty map. So we can do the same thing, actually, just using default parameters for these arguments. So we can say ingredients is, by default, an empty list. And directions is, by default, an empty list. So you can leave off one or both of those, and that works okay. So let's show how this works. Open up the console. We can construct a recipe with no arguments at all, and that says that we have an empty list of ingredients and an empty list of directions. We can say new recipe with just a list of ingredients. But no directions. And it turns out that there's actually a way to construct a recipe with just a list of directions and no ingredients. You can actually call any method with named parameters, and in that case the order doesn't matter. So we can say new recipe directions equals list of, let's just say make a sandwich. I'm getting lazy here. So that works. Now our ingredients are an empty list, and our directions are make me a sandwich. So you can mix and match these things. It's just a convenience. Another way that we could have done something similar to this is by providing an auxiliary constructor. So let's leave this here in recipe, and let's provide an auxiliary constructor in cookbook. The way that you define auxiliary constructors is by defining a method called this. Now this is a keyword that you're probably familiar with from Java, and Scala has it as well. It means the same thing. We're overloading the meaning of it here just a little bit because when we want to declare an auxiliary constructor, we use it in that case as well. So we say def this paren. You have to actually be explicit in this case about your argument list because we're in a constructor. Is equal to this with let's say map.empty. So what this is doing is providing an auxiliary constructor, that's this one, and it's chaining to the primary constructor, which is this one. It turns out that's actually the rule. Every auxiliary constructor actually has to call the primary constructor, either directly or indirectly via another auxiliary constructor. So let's prove to ourselves that that worked. Go back to our console again. New cookbook. We can see that we have an empty map of recipes. Okay. Now one more quick word before we wrap up. I just want to talk very briefly about access modifiers. In Java, you would expect to see this as a public class recipe, and all of our fields would be private, something like that. In Scala, it's actually very common to leave these things off. One reason is because everything is public by default. There is no public keyword because that is the default. And another reason to leave these off, I could, for example, say that ingredients is private and directions is private. Or I could say they're protected, right? These are the sort of things that we're used to. But it's actually very common to leave these as public as well, and the reason why is because they're immutable, right? We know that the list class is immutable, and we know that a val is an immutable reference to that list class. So it's perfectly safe to have those public, because there's no chance that somebody could come along and inadvertently modify them. You really only need to make vals private when either the object that they reference is mutable, or when the data that they contain is something that you really want to prevent access to. So that was the basics of class declarations. We've seen how to declare a class. We've seen how to provide constructor arguments. We've seen how to implement the body of a constructor, as well as populating fields directly from the constructor. And we've also seen how to chain constructors. So that sort of constitutes the basics of working with classes in Scala.